Hi, in this video, we are going to add and even subtract rational expressions with unlike denominators. So we're going to start with the most simple of examples. And for example, let's do this. Actually, let's find, this is a review from our last lesson, but find the lowest common multiple of 2, 3, and 6. Okay, well, we did this a few different ways. For example, notice that 6, or let's start with 2. 2, in its most basic form, is factors to just 2. 3 is 3. 6, though, notice that 6 is a 2 and a 3. So our lowest common multiple, notice we check our column. So in this first column of 2's, we have 1, 2, we have 1, 2 for the 2 here. Let me undo that. We have 1, 2 there, 1, 2 there, and we have 0 2's for the 3, so we need 1, 2. Okay, and then we do the same thing again for the 3 column, and we have 0, 3, 1, 3, and 1, 3. So our lowest common multiple is 2 times 3, or 6. So now let's change the problem slightly. What if I give you the problem of 1/2 plus 1/3 plus 1/6? So these are fractions or rational expressions in the most simple form, fractions with unlike denominators. So that means that we can't add them yet. We have to first find a common denominator. Well, let's do this. Find the common, find the common denominator is the same thing as find the LCM, or lowest common multiple. Find LCM of denominators. Well, we just did that. Denominators. Okay, so here we go. So let's convert each fraction so that the denominator is all in sixths. So this we said was the 6 was the lowest common multiple. Well, now it's also the lowest common denominator. So that means that we need to make each fraction have a 6 in the denominator. So we did that earlier, but let's review for this problem though. So in other words, we have to take the fraction of 1/2, multiply it by something, so that we end with a 6. Well, looking up above, we see that the 2 is missing the 3, so we're going to multiply this by 3/3. And remember, we can do that because 3/3 is just 1, and multiplication by 1 doesn't change the value, just the appearance. So the denominator works. 1 times 3 from the numerators is 3, so 1/2 has another form of 3/6. We can do this again for a third, so we need to change 1/3 into something with sixths, so how about 2 over 2? The denominators multiply to 6 now, and 1 times 2 becomes our numerator of 2. So we rewrite the problem, and let's just take this from the top. The problem began as 1/2 plus 1/3 plus 1/6. Well, now we said that 1/2 has the form of 3/6, 1/3 has the form of 2/6, and 1/6 is already in 6. So now we can add the numerators. We can add the numerator of 3 plus 2 plus 1 over 6. And 3 plus 2 is 5, plus 1 more, that's 6, 6, 6. And so we get an answer of 1. All right, let's try a more challenging example. Okay, how about this? Let's add 2y over 3, or actually, I should write the directions. And the directions would just be to simplify. Simplify 2y over 3x minus 3y over x squared. Okay, so we have, these are unlike denominators. So to find the common, or the lowest common denominator, we need to find oh, and the lowest common denominator is often abbreviated LCD. So the LCD is the LCM, the lowest common multiple, of the denominators. So here we go. So I have 3x, and it just factors into a 3 and an x. I have an x squared, which we'll put in the x's column. And it looks like my lowest common multiple is going to be 3. And then I need the, notice I have an x in both of these. I take the one with the highest count, so I need the x squared. And so 3 times x squared is my lowest common denominator. Now, we change each fraction. So for example, 2y over 3x needs to be multiplied by something to end with the denominator of 3x squared. So notice that the 3x needs an x. So x over x. So I have 2xy. And for the second fraction, I have 3y over x squared. I'm going to multiply it by something to end with a new fraction with a denominator of 3x squared. So let's see. This one just needs a 3/3. So now I have 9y. Okay, now we can take the problem from the top. So 2y over 3x minus 3y over x squared equals, now we use the new forms of these. So it's the same value, it's just a new form. 2xy over 3x squared minus the 3y became 9y over 3x squared, so minus 9y over 3x squared. So this is going to give me a 2xy minus 9y over 3x squared. And I think that's all we can do. You could factor the y's in the numerator, but they're not going to cancel with anything in the denominator. So I think we'll just stop there. All right. I hope this helped, and in the next video we're going to try an even more complicated looking piece of adding rational expressions with unlike denominators. Thanks for watching.